Hello guys, in this video, we will be discussing about finding the derivative of a function using quotient rule. Now if you could recall, quotient rule is given by this expression, y is equal to the u of x over the v of x. Now our u of x and v of x are any polynomials. And take note that our denominator here, v of x, should not be equal to 0. Otherwise, our function will become undefined. Now, how to find the derivative of this function u of x over v of x? By using the quotient rule, because we are actually given the fraction figure. Now, what is the derivative of u of x over v of x? So our derivative notation for y is y prime, or shall I say dy over dx. Now our numerator is u of x, our denominator is v of x. So according to finding the derivative, all you have to do is to copy the denominator, which is v of x, and then you have to square that. That's your denominator part. And then copy your denominator here, which is v of x. And then multiply that with the derivative of the numerator denoted as u prime of x, minus copy your numerator part, which is u of x, and then multiply that with the derivative of the denominator denoted as v prime of x. In short, in finding the derivative of your function, make sure to make use of this formula. So we can actually copy the denominator, square that, copy the denominator, multiply with the derivative of the numerator denoted as u prime, minus copy your numerator and then multiply with the derivative of the denominator, which is v prime x. But other source, okay, to make it neat, others are just actually using the u and the v. So others would say v and then square that, copy the v, the denominator, multiply with the derivative of the numerator, which is u prime, minus copy your numerator, which is u, and then multiply with the derivative of the denominator, which is v prime. So instead of using this long expression in finding the derivative of the function u of x over v of x, you can actually use this symbol. Y prime is equal to the v times the u prime minus the numerator times the denominator derivative over the v squared. You can actually use this. Or others would say v times du minus u times dv over v squared. You can also have that. So in answering this function x over x minus 3, we are going to base on the quotient rule because this is in a form of a fraction. Now our numerator is our u, if you will try to look at from this expression, and our denominator is corresponding to the v. Now in finding the derivative, all we have to do is to copy this formula here, or the second one. Now in finding the derivative, make use of the symbol y prime, or dy over dx. Now all you have to do is to copy the denominator and then square that. So our denominator v is x minus 3, so we have here x minus 3 squared. What is your v? X minus 3, write that here on your numerator, times, what is u prime? Your u prime is the derivative of x, which is 1, minus, what is your u? Your u is just x, your numerator, times, what is v prime? The derivative of the v, or the derivative of x minus 3. This is no difference rule, so get the derivative of the first term and the second term. But the first term is actually 1. That's the derivative, but the derivative of the second term is 0 because this is constant. So the derivative of the denominator is just 1. Simplifying, so we have here y prime is equal to x minus 3 times 1. Any function multiplied to 1 is a function, so just copy x minus 3. And then negative x times 1, that's negative x. Over, copy, we have here x minus 3 squared. Now, simplifying our numerator, we have here x minus 3 minus x. So what is x minus x? That is 0. What's left? Negative 3. Over, just copy x minus 3 squared. At this point, we are not actually expanding x minus 3, or shall I say, we are not multiplying x minus 3 by itself. It's because there are cases that we don't need to expand our denominator because we have something to cancel on the numerator after simplification. But in this case, we don't have something to cancel on with x minus 3 on the numerator. So all you have to do is to copy, retain, or you can just expand. So what is the expansion of x minus 3 squared? That's x squared minus 6x plus 9. Okay? Or you can just write that here on this part right away. So what is x minus x? It's 0. So copy negative 3 over. All you have to do is to copy x minus 3 raised to the power of 2. So this is now your answer. You can actually do that, or you can actually write that on this part. Another example, we have here 4x over x plus 5x squared. Take note, our numerator is our u and our denominator is our v. If you will try to look at our definition of the quotient rule. But there are cases that you have to factor something, especially on the denominator part or the numerator, because you have something to cancel on before finding or getting the derivative. So on the denominator part, there is actually a common, which is the x variable, so we can actually factor that out first. So copy y because we are not yet finding the derivative. So this is now equal to 4x over x, and x is actually common on the two terms, so we can let that out. What's left in the first term if we're going to take the x? That's 1. Plus what's left on the second term if we are going to take 1x, so that will become 5x. Now if you will try to distribute x to 1, so x times 1, that's x. And then x times 5x, that will become 5x squared. So this and this one are actually the same. Now why are we going to factor the denominator? Because we are going to cancel x variable. So what's left on the numerator part will become 4 over 1 plus 5x. So we have now a reduced figure of our function 4 over 1 plus 5x. So this is now our u, and this is now our v. Now in getting the derivative, all we have to do is to follow the same formula that we are actually writing here. So this is now y prime. At this point, we are finding the derivative. So make use of this prime. So by following the formula, what is v?